Hi, I'm Ted Wei, and I'm a program manager on the Azure Machine Learning team. Today, I'll be talking about machine learning on the cutting edge. This means using the power of the cloud with elastic compute and storage to train machine learning models and then deploying them to edge devices. To illustrate this, let me talk about work that Schneider Electric is doing when they pump oil. Schneider has a SCADA system, which stands for Supervisory Control and Data Acquisition. Sensors attached to the equipment from the pump is collected by their system, and they want to make their SCADA solution proactive by being able to do predictive maintenance of their equipment. At the well site, we have added a gateway device, and this device has been registered with Azure IoT Hub, and it runs Azure IoT Edge. Now, a traditional IoT scenario would look like this. An edge module has been created that can collect the data from the Schneider Electric system. In technical terms, it's collecting Dynacards data from the RTU over Modbus. If the IoT edge device is connected to the internet, this module can send data to Azure for remote monitoring. Today, I'm happy to announce that all machine learning models created using Azure ML are compatible with Azure IoT Edge, and these models can now be deployed to edge devices. As you may already know, Azure Machine Learning enables you to create machine learning models that are operationalized as Docker containers with REST APIs. These containers can now talk to the IoT Edge runtime and be part of pipelines on edge devices. In this case, you can imagine using Azure ML to create an anomaly detection model. This model is operationalized as a Docker container, and then using IoT Hub, it's deployed to this edge device. When an anomaly is detected, it can notify the SCADA system to adjust the pump operation or to stop it. If there's an alert, the SCADA system can even send out an email or text if there's connectivity. The output of the ML model and the data from the equipment can also be sent back to the cloud for storage and to train more accurate models. Azure Machine Learning is a modern platform for machine learning and data science. Intelligent data prep is important because data scientists tell us they spend 50 to 80% of their time on data wrangling and preparation. Using the Azure ML Workbench companion app, you can take advantage of ML-assisted data wrangling by providing examples of data transforms and having it take care of the rest. You can sample large data sets locally and then apply the transforms to big data in the cloud. Agile experimentation enables you to train your model using the compute context that makes the most sense. For example, you may want to iterate quickly on your local machine. Or you want more RAM, you can scale up to a data science VM on Azure. You can scale out to a Spark cluster or even a GPU cluster to run your training jobs. As data science teams grow and organizations rely more on machine learning models, lifecycle fundamentals become critical. Knowing who created the model, the source code, where that model is deployed, enables you to reproduce models and audit them. Each experiment run for your model is checkpointed in a Git repository so it's accessible to your entire team. Finally, a model is only valuable when you can use it on your production data. Typically, data scientists hand off models written in Python or R to developers who translate that to Java or some other language to run in the data center. With Azure ML, you can use the framework of your choice, such as Python, PySpark, Microsoft Cognitive Toolkit, or even TensorFlow. The model is packaged as a Docker container, and you can deploy it to anything that can run a Docker container, now including Azure IoT Edge devices. Azure IoT Edge is all about enabling cloud services at the edge. For example, models built with Azure Machine Learning, near real-time analysis of streaming data with Azure Stream Analytics, event-driven execution of code with Azure Functions, or you can even create your own custom code and package that in a Docker container. All devices and services can be managed from the cloud using the Azure portal. And by bringing intelligence to the edge, you can run analytics in places where it's intermittent, low, or even no connectivity. There is reduced latency because compute is brought to the data. The data doesn't need to travel to the cloud, which reduces bandwidth costs. If your data is private, sensitive, or impossible to send to the cloud, IoT Edge brings compute to the data. And let me show you how this could all be done. Here's a picture that I want to classify. I'll start with using Azure ML to train a model that will take in this image, recognize what kind of flower it is, such as a dandelion, rose, sunflower, or tulip, Then I'll package this model as a Docker container, which will then be deployed to an edge device. Here I am in VS Code, and I'm going to train my model. I can submit my training job to my local machine or to an HD Insight Spark cluster. Very soon, we'll enable you to submit training jobs to GPU clusters with Azure Batch AI. Now I'm switching over to the Azure ML Workbench, which is a companion app that can run on Windows or Mac. Here is the run history view, which shows the outputs for each experiment run. I can change the parameters of my model and see how that affects my training accuracy. I can compare runs and choose the one that resulted in the highest accuracy. Now I'm switching over to the Azure CLI. This is the command that I'll run to take the model artifacts, which in this case is the model serialized as a pickle file. What will happen is that this model is registered with our model management service, and a container image is created and deployed to Azure Container Registry. I'm now jumping over to my edge device. This is a Linux box that I've registered with IoT Hub, and I've installed the IoT Edge runtime. In the Azure portal, I've configured the Docker images to deploy to this edge device, and they've been instantiated here. You can see I have an image classifier container that will read in an image. And I'm just having it read in the image of a dandelion, just to keep it simple. With this IoT Edge CLI command, I'm monitoring the output of my model. And you can see that it's analyzing the image and correctly identifying it as a dandelion. You saw that I was able to use Azure Machine Learning to train a model, operationalize that to a Docker container. I deployed that container to an IoT Edge device, and now I'm able to recognize flowers without having to send the image to the cloud. So I encourage you to create your own machine learning models with Azure ML, and then deploy them to Azure IoT Edge devices. We have extensive tutorials and documentation to help you out. I can't wait to see how you will take machine learning to the cutting edge. Thank you.